The USS Carney spotted it first. November 2023, Red Sea. A missile, still on the ground in Yemen, 200 miles away. The ship's computers started screaming warnings before the Houthi rebels even pressed the button. By the time that missile left the launcher, the Carney had already decided how to kill it. Sounds like science fiction, right? Except it happened. And it keeps happening. So how does a Navy ship see a missile before it launches? Keep watching and find out. Let's rewind a bit. Most people think missile defense works like a really expensive game of skeet shooting. Missile goes up. You track it. You shoot it down. Simple, except that's not how it works anymore. Not even close. The modern US Navy doesn't wait to see the missile. It watches the guy thinking about launching the missile. It watches the truck carrying the missile. It watches the fuel being loaded, the launcher being positioned, the radar turning on. By the time that missile actually fires, the Navy's already 3 steps ahead. The system that makes this possible, it's called the Aegis Combat System. And no, that's not a typo. It's named after Zeus's shield in Greek mythology, the one that supposedly protected the gods. Fitting, considering what it does. But Aegis isn't just one thing. It's more like the conductor of the world's most paranoid orchestra. Radar, computers, weapons, satellites, other ships, aircraft. Everything talks to everything else. And they're all watching. Always watching. The main radar on an Aegis ship is called the SPY-1. That stands for Scanning Phased Array Radar. Catchy, right? But forget the name. What matters is this thing can track over 100 targets simultaneously while searching a volume of airspace the size of New Jersey. And it does this every single second. The SP-1 has 4 flat faces, each one about 12 feet across. They're arranged in a square around the ship's superstructure. No moving parts, no spinning dish, just thousands of tiny radar elements working together, sending out invisible beams that sweep across the sky faster than you can blink. Here's the party trick. While most radars are busy scanning in circles like a lighthouse, the SPY-1 can look at multiple places at once. It's like having eyes that can focus on different things independently. One face tracks a dozen aircraft. Another watches for cruise missiles hugging the ocean. A third monitors ballistic missile trajectories. The fourth, probably judging you for questioning its multitasking abilities. But seeing the missile in flight is the easy part. The hard part is seeing it before it launches. And that's where things get properly wild. Every missile site has a signature. Before any missile flies, stuff has to happen. Radars power up. Launch vehicles move into position. Fire control systems activate. Communications increase. All of this creates electromagnetic emissions. Radio waves. Radar pulses. Data links. And the Navy collects all of it. This is where the E-2D Advanced Hawkeye comes in. It's that weird-looking plane with the giant rotating disc on top. Like someone strapped a flying saucer to a propeller aircraft. Looks goofy. Acts like a god. The Hawkeye flies high, around 25,000 feet, and that radar disc rotates 6 times per minute. But it's not just looking for aircraft. Modern Hawkeyes can detect missile launches from over 300 miles away. They can track the radar emissions from enemy fire control systems. They can even detect the radio chatter when hostile forces are preparing to shoot. And here's the beautiful part. The Hawkeye talks directly to Aegis ships. Everything it sees, they see, in real time. The Navy knows about it within seconds. But wait, there's more. And yeah, you're allowed to groan at that one. The Navy doesn't work alone. It's plugged into a massive intelligence network that includes satellites, drones, cyber operations, and probably a few things we're not supposed to know about, classified and all that. Let's talk satellites for a second. The US has something called the Space-Based Infrared System, or SBRs. These satellites sit in geosynchronous orbit, about 22,000 miles up, staring down at Earth with infrared sensors. They're looking for heat. Specifically, the kind of heat that comes from missile engines. When a ballistic missile launches, it burns hot, really hot. The plume from a rocket motor can reach temperatures over 5,000 degrees Fahrenheit. To SBRs, that's like someone lighting a flare in a dark room. Instant detection. The satellite spots the launch, calculates the trajectory, and transmits the data to Earth stations. From there it gets pushed to Aegis ships in less than 30 seconds. Sometimes as fast as 10 seconds. That's faster than most people can send a text message. But SIPSWERS doesn't just watch for launches. These satellites have gotten so sophisticated they can detect missile tests, track re-entry vehicles, and even spot aircraft taking off from certain airbases. The infrared signatures are all different. The computers learn to tell them apart. So now you've got ships with God-tier radar, aircraft watching everything within 300 miles, and satellites staring down from space. But the real magic happens when you combine all three. This is where the Navy's obsession with networks pays off. The system is called Cooperative Engagement Capability, or CEC. It sounds boring. It's anything but. Here's how it works. Every sensor, every radar, every aircraft, every satellite feed gets pooled into one massive shared picture. Ships don't just see what their own radar shows. They see what every other ship sees. What the aircraft see. What the satellites see. Everything. It's like having 20 pairs of eyes that all belong to the same brain. If a missile launches in Yemen, the destroyer off the coast of Israel knows about it instantly, because a satellite 22,000 miles up saw the heat signature and an E-2D 200 miles south picked up the trajectory. This shared awareness creates something insane. A ship can fire a missile at a target it can't even see with its own radar, using tracking data from another platform entirely. That's not speculation. The Navy has done this in tests. Multiple times. The USS Desert Ship, a land-based Aegis test facility in New Jersey, shot down a ballistic missile using tracking data from a satellite and another ship. The Desert Ship never saw the target with its own radar. It just trusted the network. The missile died anyway. But let's get back to the original question. How does the Navy see a missile before it launches? The Navy watches everything. Troop movements, vehicle convoys, supply chains, fuel deliveries. When a missile unit starts preparing for a launch, there are signs. Equipment moves. Communications increase. Certain vehicles show up in certain places. Intelligence analysts feed this information into predictive models. They're based on decades of collected data about how missile forces operate, how long it takes to set up a launcher, how crews communicate, what vehicles need to be present, what radars turn on in what sequence. So when analysts start seeing these patterns, they flag locations as potential launch sites. Then the surveillance assets focus on those areas. Drones loiter overhead. Satellites adjust their orbits for better coverage. Ships move their radars to watch specific zones. And here's where it gets a bit creepy. Modern Aegis systems can put specific geographic coordinates on a watch list. If any radar return, any electronic emission, any heat signature pops up in that location, the system alerts the crew immediately. Imagine a missile battery in Yemen getting ready to fire. The launcher moves into position. The crew starts their pre-flight checks. They power up the missile's guidance system. That guidance system starts talking to the launch vehicle. Radio signals, data links, and the Navy is listening. Not just listening. Recording. Building a pattern. The E-2D Hawkeye picks up the radio chatter. The signals intelligence guys recognize the communication protocols. They know what type of missile is about to launch based purely on the electronic signatures. They know it before the crew on the ground has even finished their checklist. The Hawkeye transmits this to the Aegis ship. The ship's combat system automatically calculates threat parameters. Missile type, probable target, time to intercept. It places the launch site under continuous radar surveillance. So when the missile finally fires, the ship isn't surprised. It's been waiting. The radar is already pointed at the right piece of sky. The defensive missiles are already spun up and ready. The fire control solution is already calculated. From the ship's perspective, this isn't a surprise attack. It's a scheduled appointment. Now let's talk about reaction time, because this is where the numbers get stupid fast. A cruise missile flying at 500 miles per hour takes about 24 minutes to cover 200 miles. That sounds like a lot of time. It's not. Track it, identify it, decide to engage it, and actually shoot it down. You've burned through most of that time. But if you know the missile is coming before it launches, suddenly you've got extra time. Time to position ships. Time to launch aircraft. Time to get additional sensors in place. Time to coordinate with other assets. Their newest ship-based interceptor can reach out over 200 miles, but it takes time to fly that distance. Depending on the trajectory, if you wait until the enemy missile is halfway to your ship before you shoot, you might not have enough time for your interceptor to get there. But if you shoot the moment the enemy missile leaves the ground, you've got the entire flight time to work with. Your missile can intercept theirs over enemy territory, nowhere near your ship. This happened in the Red Sea, multiple times. Houthi forces launched missiles and drones towards ships in the area. The U.S. Navy shot them down so far from the intended targets that the debris landed back in Yemen. The ships were never in danger. The missiles never got close. That's not luck. That's math. And early warning. But here's something most people don't realize. The Navy isn't just watching for missiles. They're watching for everything that might threaten a missile launch. Certain ships carry the AN/Celis ELQ-32 electronic warfare system. It's a monster. This thing can detect, identify, and locate radar emissions from hundreds of miles away. Enemy ships, enemy aircraft, missile batteries, fire control radars, all of it. When a hostile force turns on a fire control radar, they're basically announcing their position. The SLQ-32 hears it immediately. The combat system logs the location. The ship knows exactly where the threat is, even if it can't see it visually. More importantly, the system knows what type of radar it is. Every radar has a unique signature, a fingerprint. Russian radars, Chinese radars, Iranian radars, North Korean radars. They're all in the database. So when a specific radar turns on, the system doesn't just say, "Hey, there's a radar." It says, "Hey, there's a Russian S-300 surface-to-air missile system at these exact coordinates, and it just went into active targeting mode." That's the kind of information that changes battles. You're not guessing about threats. You know exactly what you're facing and where it is. Now combine this with another capability. Aegis ships can share targeting data with aircraft, with other ships, and with land-based forces. If a ship detects a missile battery preparing to launch, it can pass those coordinates to an FA-18 Super Hornet, carrying anti-radiation missiles. The Hornet can kill the launcher before it ever fires. That's preemptive defense. You're not just blocking the punch, you're breaking the guy's arm before he can throw it. The Navy tested this concept in exercises. An Aegis destroyer detected a simulated enemy radar emission. It passed the coordinates to an aircraft. The aircraft launched a missile at the radar site. Total time from detection to weapon impact: under 5 minutes. And the destroyer that started the whole chain. It never fired a shot. It just pointed. This is the future of naval warfare. It's not about having the biggest guns anymore. It's about having the best sensors and the fastest networks. Information dominance beats firepower every single time. Let's talk about one more piece of this puzzle. The Navy has started deploying something called the SPY-6 radar. It's the replacement for the SPY-1, and it's genuinely scary. The SP-6 is 35 times more sensitive than the SP-1. That's not a typo. 35 times. It can detect objects with a radar cross-section the size of a golf ball from over 200 miles away. It can track ballistic missiles in the boost phase, when they're still accelerating upward. More importantly, it can do all of this while maintaining awareness of everything else in the battle space. Cruise missiles, aircraft, surface contacts, even small drones, all at once. The processing power required for this is insane. We're talking millions of calculations per second. And because it's a newer system, the SPY-6 integrates better with everything else. Satellites, drones, other ships, cyber systems. The network just got tighter. Ships with SP-6 radar started joining the fleet in 2024. The USS Jack H. Lucas was the first, more coming. By 2030, a significant portion of the destroyer fleet will have this capability. That means the Navy's early warning network is about to get exponentially better. Missiles that used to be hard to detect will become easy. Launch sites that used to hide in ground clutter will stand out like lighthouses. But there's a darker side to all this. The better your sensors get, the more paranoid you become. When you can see everything, you start to question everything. Is that truck carrying missiles or supplies? Is that radar test or a targeting solution? Is that aircraft on a patrol or moving into strike position? The Navy has to make these judgments constantly, under pressure, with incomplete information. And the stakes are high. Wait too long to react, and a missile gets through. React too fast to the wrong signal, and you might shoot at something that wasn't actually a threat. This is why human operators are still in the loop. The computers can see everything, but people make the final call. In the Red Sea operations, Navy crews made hundreds of these decisions. Most of them were routine. Some were not. Every single time. They had to balance aggression with restraint, knowing that one mistake could mean disaster. They got it right. Every time. So to wrap this up, the Navy doesn't see missiles before they launch because of one magic system. It's the combination of everything. Satellites watching from space, aircraft watching from the air, ships watching from the sea. All of it connected, all of it talking, all of it feeding into a shared picture that updates in real time. When a missile finally launches, it's not a surprise. It's the end of a sequence the Navy has been watching for minutes, sometimes hours. The launch is just confirmation of what they already knew was coming. And that's the real advantage. Not the ability to shoot down missiles. That's table stakes. The real advantage is knowing they're coming before they arrive. It turns defense into a chess game instead of a knife fight. The US Navy has been playing chess while everyone else is still learning checkers. And they're very, very good at it. If you found this interesting, hit that subscribe button. There's more where this came from.